Hello and welcome to Minerals, Rocks, and Fossil Talks. I'm your geology teacher, Jen, and it's time for Field Trip Friday. I'm here on the Wasatch Fault, which conveniently is right above my neighborhood. So, say hi, Braxton.
Hello.
Okay, so I'm going to show you some cool things about this fault. So the first thing is I've got this fancy schmancy tool here. This is a geologic compass, and I'm going to use it to tell me what the approximate dip of this fault is. So basically, how steep is this fault? Alright, I'm going to hand the phone over to Braxton so he can show you what I'm doing. Okay. You can turn the camera around so that you can actually see. No, like... No, now turn it so you can see. So that you know you're getting the right thing. Okay, so what I'm going to do, because this fault is in some modern alluvium, which means it's loose, unconsolidated stuff, I'm going to pretend like this flattish surface is my bedding plane, okay? I'm going to take my compass, I'm going to set it on here, okay? I've got this little knob on the back that I can move. What it's going to do is it's going to move this long level in here, if you can see it. And I'm going to turn it until the bubble levels out in the level there. So I'm going to spin it until my bubble levels out. Ooh, we're close. Oop, too far. Gently, there we go. Okay, it's in between the lines, so that's good enough. Okay, so now I'm going to take the reading that's, my north is in the way. So it's about 45-degree dip, okay? So what that's telling me is that this is about 45 degrees steep, essentially. Okay. The other thing I can do is I can take a strike, which is going to tell me approximately what direction this fault is going in. Okay. So I'm going to use my geologic compass to do that as well, and I'm going to show you how that works. Okay. So this time I'm going to use this level with the little bubble to figure out my strike, using the same bedding plane. Okay. So, I can't get my hand where I need it to. Alright, so we're leveled at about there, so we're at about there. Oh, I can't get it to stay. Did you get the idea? Stay. Right. Okay. Looks like it's at about 325 degrees. 325 degrees. So we've got a sort of north-south-ish strike. Okay. So that's just some fun things to learn about our fault and how to measure it. Now the other cool thing about this fault is that if we look across this valley, you'll see there are mountains on the other side. Those are the Ochre Mountains. Okay. And then we have a valley, and then we've got mountains that are behind me that you currently can't see. So we're gonna move uphill a little bit. We're now at the top, and now you can see we have mountains behind us. Those are the Wasatch Mountains. Okay, so we got mountains, valley, mountains. We are at the very edge of the Basin and Range Province. Now the Basin and Range Province, well, is an extensional fault system. So basically, if we have our pieces, we have a lot of normal faulting, so our valleys drop from our mountains, which kind of grow up. So we get this mountain, valley, mountain, valley, mountain, valley thing going on as the land is pulling apart. So our fault is one of those extensional faults. And to give you an idea of just how big this fault is. Okay, here I'm at the top. That's Walmart. You can see the top of Walmart. This is a very, very tall fault. I would tell you exactly how tall, but I don't know the number off the top of my head, and I don't have a Jacob staff on me to measure it, so you're just gonna have to take my word for it that it's a big, tall fault.
I'm gonna go with a lot.
It is a lot, especially if I can see the roof of Walmart. But there you have it. That's the Wasatch Fault. And I bet if you dug through the sediment, you could find like slicken lines and things like that, which are, I have an example back at home that I can show you. But it's basically lines you get from the rocks scraping against each other. So, you know, cool stuff like that. Anyway, I will finish this up at home. Okay, so I said I would give you a little more background when I got home. So here we go. So the Wasatch Fault is actually broken up into these chunks because it goes clear from southern Idaho all the way down to Fayette, Utah. So very long fault. And it's broken into chunks. So where I'm at is in the Salt Lake chunk right here. And even that part of the fault is broken into smaller bits. So I'm specifically at the Cottonwood section. And the fault scarp, which is what I was on, is about 100 feet. Okay, 100 feet worth of offset seen, which is super big, but also super neat. Overall, the Salt Lake segment has accumulated between 52 to 60 feet of vertical displacement since the retreat of Lake Bonneville. So it's had quite a bit of offset. Oh my goodness, sorry, yawn. Not getting enough oxygen, I guess. I need to breathe better. But on average, it moves about 1 millimeter a year. Like, it's really not very much. It moves about as much as we do from Europe. Anyway, there you go. Just some stuff about this fun fault. Hope you learned a lot today. And I will fossilize you later.